Okay, so find the measure of each angle. The figure's not to scale. So, okay, they're giving us the 104. That 104 is out here. A little better job there. That 104 is an external angle. See how that's outside of that triangle? Is that 104? It's not in the triangle. And then notice these marks right here. This mark and this mark. Those marks mean the sides are equal. Two equal sides, huh? So that's when they put those same marks like that, they're saying those two sides are equal sides in those triangles. Okay, so and what they want us to find on this problem is angles 1, 2, and 3. So angle 1's right here, angle 2's right there, and angle 3's right there. Those are the three they want us to find. Okay, so really it's not clear right now, probably to your mind, like how to find angle 1 directly. So what we should do when you run into a situation like this and you're looking, you're going, I don't know how to find angle 1. I mean, look at it. It's just, I don't know, it's up there. It's totally in a weird place. I have no idea. Well, really what you should do is just start doing anything you can do. And hopefully, eventually, kind of like dominoes, you'll get to the big ones you want coming down the line. So just start doing anything you can do. And specifically, we can find this angle here, can't we? Even though that's not angle 1, we can find it. How so? We can find that angle because the fact that one side of a line holds 180 degrees, right? One side of a line holds 180 degrees. So this angle and this angle together are one side of a line. They are the top of that line, aren't they? So they have to hold 180 degrees. So therefore, I can find the other angle by taking 180 minus 104, which equals, what's that, 76? Yeah, so that angle here has got to be 76. That making sense? Because then those two, the 76 and the 104, make 180. They make one side of the straight line. Remember that? Remember, all the way around a circle is 360 degrees. Therefore, halfway around a circle is half of that 180, which is one side of a straight line. So, okay, so we've got that 76 over there, even though that's not one of our one angle. That's not angle 1, 2, or 3. It's still something. It'll help us. So now, how can we use that to find angle 1? Which is the first one they want us to find. How can we use that fact to help us find angle number 1? What I think is going to help us to do is to realize another fact. If you have a triangle, let me draw a little triangle. Like that. If you have a triangle like that, and these two sides are equal, what kind of triangle is that called? Anybody remember the name of a triangle with two equal sides like that? It's okay, you don't have to memorize these. You can use them. It's called isosceles. You can use your notes on the exam. Isosceles triangle, two equal sides. Well, do you know what that means? That also means two equal angles across from those sides. So in other words, this angle and this angle, which is across from that one and across from that one. So not the top angle up here, not this guy, he's different, right? He's a small angle, you can tell. But these two angles, which are across from those two sides, they have to be equal as well. It looks right, doesn't it? Right? If those two sides are equal, then the two angles are also equal. Okay, is that really important? Yeah, actually, that'll really help us out because now we know. Oops, let me go back there a little bit. I erased too much. There we go. Because now we know that this has got to be 76 also. So we've got angle 1. They've got to be the same, don't they? Because those two angles are the two angles across from the two equal sides. See how those are the angles? And so it's not this angle up here. That one's across from this side, which is different, right? This side is across from this angle. We're not talking about that. We're talking about this side, which is across from that angle. And we're talking about, which is equal to this side, which is across from that angle. So those two sides are equal, and therefore the angles across from them are also equal in that little isosceles triangle. So if this one's 76, that one's got to be 76 also. We found angle 1. We've got it. All right, we're getting there slowly. How about, do you see a way we can find this angle here? Let me change up the color here. How can we find this angle here? In fact, we're going to have to use triangle, the 3 angles, total 180 degrees. Huh? So we've got 2 out of 3 of the, whenever you have 2 out of 3 of the angles in a triangle, you can always find the third one by subtracting from 180 because the total in every triangle is 180. So we just say, oh, okay, 180 minus 76 minus 76, 142, is it 28? 28. Yeah, 28. So that one's got to be 28 degrees, doesn't it? And now, how can we get 180? 180. How can we get angle 2? Angle 2, and that one have to make 180, don't they? That's what I was thinking. Right? Does everybody see that? Because that's one side of a straight line again, isn't it? One side of a straight line. Let me highlight that for extra clarity. So if you highlight this line, so it kind of jumps off the page for you, or I guess the screen. We don't have pages. We never use pages anymore. That line right there, the 28 and angle 2, one side of a line holds 180 degrees. So therefore, angle 2 is going to equal 180 minus 28. Everybody seeing that? Because the angle 2 and the 28-degree angle together make the top of that purple line. So therefore, angle 2 is going to be, I don't know what, 152. 152. So we've got angle 2. We're getting close now for angle 3. Maybe we could use a couple of facts here. For angle 3, we can find this angle here, can't we? Do you see why? Do you see that's got to be 28 because it's diagonal? So let me call that another fact here. Fact. So we're using a lot of different facts in this problem. Diagonal angles are equal. They're called vertical. Even though I don't like that name, because vertical to me means up and down, and they're not up and down. So vertical angles called vertical, they're diagonal. So this one has got to be 28 because it's diagonal from the other 28. There we go. What do we got left? So we got angle 3 is all that we have left, and you can see it, right? Part of a triangle for the 180. We got it. So we have basically arrived. So triangle 180. So that means that we can say, okay, triangle holds 180. So that means angle 3 is going to be 180 minus the 28 and minus the 90. Because we have 2 out of 3 of the angles in that triangle. So then angle 3 is 62, I think. Yeah, 62. Angle 3 is 62 degrees. So there we go. That was a lot of steps and a lot of different facts we used to navigate our way through that one. So let me recap again. We started up here. We knew this was 104, so we found this to be 76 right there because a line holds 180. So the 104 in this one, that was 76. And then fact number 2, an isosceles triangle with 2 equal sides, has 2 equal angles as well. And so we said, okay, so these angles had to be equal. So I knew this was 76, so that was 76. And then we had 2 angles in the triangle, so we could subtract to find the third. Found that is 28. And then the 28 and the angle 2 made one side of a straight line. So subtract. Angle 2 is 152. I never wrote that in right here. 152. Right there. And then from there, 28 and 28 had to be equal because they're diagonal. That was that fact right there. Diagonal angles are equal. And then I had, in this triangle, 2 out of 3 angles. Triangle holds 180. So 180 minus 28 minus 90, I found angle 3. There we go.